Hey there, and welcome to this explainer. Today, we are going to track the fascinating and honestly pretty wild journey of a single fast delivery app order as it travels through databases, lakes, and warehouses. I know, it sounds like some heavy technical plumbing, but by following just this one order, we're going to completely demystify how modern companies actually handle their massive amounts of information. Let's get right into it. Here's a quick look at our roadmap. We'll be breaking down the alphabet soup of data engineering into 6 clear steps. We'll start with the data behind your app, look at the analytics problem, walk through extract, transform, and load, enter the data warehouse, dive into data lakes, and finally, check out the modern data lakehouse solution. Okay, so imagine you're running a massive fast commerce service. Think something like Blinkit in India, and you are promising deliveries in tight 30-minute windows. As the CEO, or even a business manager, you need the answer to a seemingly simple question. What exact percentage of your orders were delivered in full and on time over the last 6 months? Now, it sounds like basic descriptive analytics, right? But actually getting that answer requires a surprisingly complex data ecosystem. Section 1. The data behind your app. To really understand the bottleneck here, we have to start at the exact moment a customer taps buy on their smartphone. Your app is creating so many different shapes and sizes of data, all at the exact same time. Your new order drops into a nice structured Postgres database, while your store inventory sits over in MongoDB. Meanwhile, you've got unstructured data, like chatbot transcripts dropping into an Amazon S3 bucket, and live delivery driver locations streaming in constantly. It is literally a massive, multi-lane highway of information. Now, all of this live, incoming data flows directly into your OLTP database. That's online transaction processing. This is a mission-critical system, and it has one vital job, ensuring that when someone orders groceries, the transaction happens instantly. No lag, no crashing. It flawlessly handles the immediate, high-stakes reality of the business. Moving to Section 2, the analytics problem. So, you've got all this great data flowing in, but analyzing it to answer our CEO's question, that creates a massive bottleneck. You might be wondering, well, why can't a data analyst just run a heavy query right on that live Postgres database to find the on-time delivery rate? I mean, just write some SQL, join the tables on the fly, and boom, you have your answer, right? Actually, no. And here is the absolute crucial point. Your transaction database is mission critical. If a heavy query slows it down, your customers literally cannot place orders. The app crashes. So, if an analyst tries querying 6 months of complex historical delivery records, they are going to drag the performance of that live database to a grinding halt. Analytics are technically secondary, which means you absolutely cannot touch your mission-critical OLTP data where live customer transactions are happening. Section 3. Extract, transform, and load. To prevent those catastrophic outages and actually make the data usable, we have to create a specialized copy. We do this through the ETL process. First, you extract. You pull the raw data from your live databases. Then you transform it. This means you're cleaning up bad values, converting currencies, matching order quantities, all that good stuff. Finally, you load this newly minted analytics-ready data into its safe new home. Section 4. Enter the data warehouse. Once your data is perfectly transformed, it lands right here in the data warehouse. This is an OLAP system, which stands for Online Analytical Processing. And unlike your live transaction database, an OLAP system guarantees consistency and is highly optimized for performance when you're running those massive, complex business queries. Because the data in the warehouse is so perfectly clean, structured, and isolated away from the live app, tools like Power BI can easily hook into it. And just like that, analysts can instantly answer our CEO's question. They can query this clean data all day long, discovering that 85% of orders were delivered in full and on time without ever risking a single app crash. Section 5. Diving into data lakes. Now, there is a bit of a catch to data warehouses. They are incredibly powerful, yes, but they're also super expensive, and they only really like structured data. You can't just store 2 decades of messy, unstructured chat transcripts in a premium warehouse. So before data even hits the warehouse, companies usually dump everything into cheap cloud object storage, like Amazon S3. We call this a data lake. Think of it as a massive cloud dump yard that keeps an incredibly affordable historical audit trail of absolutely everything. To put it simply, a data lake is kind of like a big bag of cheap, dirty vegetables you just brought straight from the farm. The data warehouse, on the other hand, is your perfectly washed and prepped veggies sitting in the fridge, ready to cook.
The lake is super cheap and takes absolutely anything you throw at it, while the warehouse is a premium VIP environment exclusively for your clean, structured data.
Section 6. The Data Lakehouse Dilution.
So we have cheap lakes for raw history and expensive warehouses for clean analytics. But what if you could just merge them? Well, tools like Delta Lake by Databricks and Apache Iceberg have done just that, creating what's known as the Lakehouse. It's a real game changer. It gives you a unified platform that combines the massive, super cheap storage of a lake with the strict structures and high-performance querying of a warehouse. Literally the best of both worlds. Getting this whole architecture right is absolutely vital today. Why? Because this data isn't just for analysts looking backwards at the past anymore. It's the fuel for your AI. With decades of perfectly clean information from a lakehouse, your AI teams can basically act like astrologers. They can accurately predict exactly how customer satisfaction and revenue will respond to specific discounts next Christmas. So now that you know the plumbing behind the scenes, you have to ask yourself, what future business decisions will your clean data predict next?